Hello, welcome. We're going to work through the problems assigned out of section 5.5. So write the following expression as a sum or difference of logarithms and express powers of factors. So we'll see exactly what this means. We just want to use properties of logarithms to play around with these things. The goal is not really to compute anything, it's just to get comfortable manipulating logarithmic expressions. And the laws of logarithms we're going to use is that the logarithm of any base of x times y can be rewritten as the logarithm of x plus the logarithm of y. Also, the logarithm of any base of x over y can be written as the logarithm of x minus the logarithm of y. The logarithm to any base of a power, x to the y, can be written as y times the logarithm of x. These are the primary laws of logarithms that we're going to be using here. So notice we're taking the logarithm base b of u to the fifth times v to the fourth. Fundamentally, the first operation I want to take care of is that multiplication. So I'm going to call this the logarithm base b of u to the fifth plus the logarithm base b of v to the fourth. And what we've used is this law of logarithms right here. The logarithm of one number times another can be written as the log of the first plus the log of the second. So the logarithm of one number, u to the fifth, times another, v to the fourth, can be rewritten as the logarithm of the first, u to the fifth, plus the log of the second, v to the fourth. Now we're going to use this law down here regarding powers. Okay, if you're taking the logarithm of a power of something, the power can be brought out as a factor. So the first step was the instruction about writing them as sums or differences of logarithms. The second step is this instruction of expressing powers as factors. Logarithm of a power, you should be able to factor that 5 out. That's what that means. Okay, so this is the expression that was being asked. So we're just going to do the same thing here. So I can write this as a natural logarithm of the first number plus the natural log of the second. And now I can bring out powers of factors. Now the first one we see like this, but don't forget that square roots are also powers. They are the 1/2 power. So I really want to bring this out as 1/2 the natural logarithm of 6 minus x. Now observe, we have this rule of logarithms that the logarithm of a ratio or quotient is a difference of logarithms. What you can't do is say the logarithm of a difference is the difference of the logarithms. This is a common error. This does not work. Don't be that person. So once we get here, where we have a natural logarithm of 6 minus x, we cannot break this up any further. If you're taking the logarithm of a product or quotient or power, then you can simplify. But the logarithm of a difference does not simplify in any reasonable way. So similarly, okay, we've got a product and a quotient. So let's deal with the quotient first. So here, we were using this law of logarithms that we haven't used yet so far in this assignment, that the logarithm of a quotient can be expressed as the difference of logarithms. And the numerator was x times x plus 4, and the denominator was x plus 6 to the 15th. So I have the logarithm of the numerator minus the logarithm of the denominator. Now that first term can be broken up as a sum of logarithms. And this second term, I can bring out the power of 15 as a factor. Again, I cannot split up this logarithm of x plus 6 in any way. Now a note on notation. Here we're just writing log, where we are leaving no base written. This can mean different things depending on who you're talking to, and I know I'm contradicting your textbook slightly here. So in the sciences and engineering, when you write a log with no base, Implicitly, you're talking about base 10. This is called the common log. Okay, also sometimes called the decimal log. However, mathematicians tend to only really work with the natural base, in which case this means the logarithm of base e, aka the natural log of x. The reason for this being that, and you'll see this much more clearly in calculus, you don't really need to discuss any logarithm other than one particular choice of base. Okay, we have seen this a little bit in the change of base formula, which hasn't come up in this assignment, but is covered in this section. So if you can readily change bases between logarithms, you only really need to ever talk about one particular base. If you are working a lot with numbers written in base 10, the common log or the decimal log is nice and convenient. And since in the sciences we use lots of big numbers, the common log is used frequently. In mathematics and in calculus in particular, however, the base e works much, much nicer for certain applications, so that tends to be the choice we make in math for what single base do we want to pick as the default. So a mathematician who simply writes log x is probably talking about the natural log, but an engineer or a physicist, for example, who writes log x is probably talking about the common log. Okay. If you're actually working on a problem with another person, by all means ask them to clarify. Now in this book it is stated that log x means common log or base 10. I'm just letting you know that if you go on through calculus, professors might accidentally write log x and mean the natural logarithm. I've made that mistake myself because in higher math, log x always means natural log. It's the only logarithm worth discussing for our purposes. So just be careful about that, but let's keep going with this assignment. Here we just need to do the reverse. We want to express this as a single logarithm. So first let's bring those factors in as powers. And now that I simply have the sum of two logarithms, I can express that as a logarithm of a product. Now what I need to be very careful about verifying is that the base of these two logarithms is the same. If the bases of these two expressions were not both 7, if they were different values, you couldn't combine them like this. Okay, the law of logarithms that we're using is the log base a of xy equals the log base a of x plus the log base a of y. And what's really quite crucial is that these two bases are the same. But hey, here we both have base 7, so this is not a problem. Okay, moving on. So again, we want to express this as a single logarithm. First, we have to account for this factor, and then we can move on to this difference. So I have a log base 4 of x squared minus 49. Then I want to subtract the log base 4 of x plus 7 to the 4th. Now I want to express this as, since they are the same base, the base is 4, a quotient, x squared minus 49 over x plus 7 cubed. Hopefully we recognize that x squared minus 49 actually factors as x plus 7, x minus 7. So I can cancel this factor with one of these for a simplified result of the log base 4 of x minus 7 over x plus 7 squared.